Well, welcome to week 6 of trigonometry. Right now it's actually Sunday, February 28th. Due tomorrow are the podcast problems 1 through 19, and then also problem set number 2, which you'll need to turn in on Canvas before the end of Monday. Also on my stat lab, there's quiz number 5, and somewhere in this video, I'll talk a little bit more about quiz number 5. Also, I'm going to be doing some homework problems from section 3.2 and 3.4 as extra examples. And I'm going to go ahead and start with section 3.2 first of all. So in section 3.2, if you have something going around a circle, and let's say it goes from this point to this point, then this is called arc length. So how much is that arc length equal to? Well, since this is a circle, we would need to know the radius, and as it moved, it would have this central angle theta. And the formula is that S equals R times theta. You just have to make sure that theta is in radians. And then on to section 3.2. The first one I picked was number 2. This one is pretty straightforward. We're just going to be using that formula that I just said. In the directions, it says find the radius. So this is section 3.2. This is question number 2. So we use S equals R times theta, and we're supposed to solve for R. So that means that they must tell us what theta equals. That would be right here, 7 pi over 4. And they tell us what S equals, so going all the way around here, it's saying that's equal to 11 pi. Then to solve for R, so what I could do is multiply by the reciprocal of this, so multiply by 4 over 7 pi, multiply by 4 over 7 pi, and these are going to cancel, these are going to cancel, so it's just R on the right hand side. And the pi's are going to cancel, so all that's left on top is 44 and then over 7. And a 7 won't divide into 44, so that would be the answer. Type an integer or a simplified fraction. So this is a simplified fraction. That would be my answer. Then for one that's a little more challenging from that section, so still section 3.2, but this is number 10. So here's the pedal for a bicycle, and here's the rear cog. And of course, they're connected with the chain. So we're going to be using this. And they gave us the angle right here, 180 degrees. But in order to use this formula right here, the theta needs to be in radians. So I do know that theta equals 180 degrees, but in radians, that's equivalent to pi. Okay, now use this formula first of all for this front cog. So how much is the arc length? So basically, if it rotates from here 180 degrees to there, then what is the arc length? So I'm going to call it first of all the large cog, or the front cog, and S equals R times theta. So S is equal to, it says the radius on my example is 4.81 in inches. And then times theta, so times pi. And I'm going to wait on typing that into a calculator and get the decimal answer later on. Now, because these things are connected with the chain, if this one goes through a length of S, then this one has to do the same thing. So for the small one, or the rear cog, also using S equals R times theta, so S equals R on that one is a 1.38, And theta, I don't know. Because it's smaller, it would have to spin around more, so its theta would actually be bigger than this one. This one would spin around slower. This one would have to spin around faster to keep up. So right now, I don't know what the theta is. I'll just have to call it theta. But because they're connected, this one's S and this one's S have to be the same. So I can substitute that in on the left side. 4.81 pi equals 1.38 theta. And then solve for theta. So just divide both sides by 1.38. So 4.81 pi gets divided by 1.38. Okay, now I'm ready to use a calculator. So 4.81 pi gets divided by 1.38, and that equals a 10.95, and that's in radians. So theta equals 10.95. Okay, now we're almost done. Now the bicycle wheel, so they didn't draw it, but the bicycle wheel would be connected to the rear cog like this. And it has a radius of 10.6. Well, because this small cog has an angle of 10.95 and it's connected to the rear wheel is going to have the same angle. So then finally for the wheel, the S is going to be R, which is 14.6 times theta, 10.95. And I can just go times, because the 10.95 is still there, times 14.6. So it's a 159.87. What did they say? They said to the nearest tenth. So this 7 would actually, so this would be a 159.9. And then the last thing is, this is in inches right now. And then I have to check, okay, they did say inches, and they said the nearest tenth. So that means that I'm actually done with that one. Okay, then on to some examples from the homework of section 3.4. So section 3.4, this is number 7. And the formula for angular velocity, so they call it speed. Speed and velocity are basically the same thing. Velocity, though, could be negative if you're going backwards, but otherwise you can use those interchangeably. So the velocity, you need to know the angle and then divide by time. So that's how fast the object would be spinning around, how fast its angle is changing. And then they're talking about the speed of the minute hand of a clock. So for a minute hand, of course we don't need to know the radius. So the minute hand would go like this when it's pointing up at the top, and then it will go around the minute hand will go around, it takes 60 minutes for it to go around. So I know that the time is 60 minutes, because there's 60 minutes in an hour. That's going to be the time, so that's t. And because it went all the way around the circle one time, that means theta is equal to 360 degrees. So the angular velocity is 360 degrees divided by time, 60 minutes. And then, let's see, I could cancel the zeros, and then 36 divided by 6 is 6, and it's in degrees per minute. Now, once again, go read the directions. Oh, they said to use radians. Well, that's okay. That just means that over here, instead of using 360, I should use 2 pi. So over here, instead of using 360, use 2 pi. So 2 pi divided by 60. This is in radians, and this is in minutes. And then when you reduce, a 2 will divide into a 60 30 times. So that's going to be pi over 30. And now it's in radians per minute. All right, then on to the last one. This is section 3.4, number 8. So we're going to be using the same S equals R times theta formula. And then velocity is distance over time, so S over T. Okay, so to begin with, S is equal to, it says that the radius is 14 inches, and it also says it makes 215, so the wheels are making 215 revolutions per minute. All right, so let's see, that means that the theta is actually going to be 2 pi. So 2 pi for 1 revolution. So for 1 revolution, the formula is going to be R times theta. So R is 14 times theta is 2 pi. And then that's going to be the distance when it goes around 1 revolution. So I'm just going to write that as 28 pi. Okay, now the 14 was in inches, so right now this is in inches. And they said to put it in miles per hour. So for one thing, I'm going to have to change this to miles. 28 pi inches needs to be changed to miles. Okay, so first of all, there is, for 1 foot, there's 12 inches, and that way inches and inches could cancel. And then they even give you this hint that 1 mile is 5,280 feet. And then feet and feet will cancel. So now this is in miles. So I'm just going to rewrite this. On top, there's 28 pi times 1, so there's just 28 pi. On the bottom, there's 12 times 5280. I'm just going to leave it that way until I'm ready to type it in the calculator. And so right now, this is in miles. Okay, now what about the time? Well, it makes 215 revolutions per minute. That means it takes 1 over 215 minutes in order to make a revolution. So 1 over 215, and then this is going to be just a fraction of a minute for the wheel to go around once. So this is for 1 revolution. Now right here, they're saying put it in miles per hour. So we need to change this to hours. So T is equal to 1 over 215. Right now, this is in minutes. And then there is 1 hour is worth 60 minutes. And then minutes and minutes will cancel. So that's going to be 1 over 215 times 60. All right, finally, use this formula. So take the S and divide by the T. So the velocity is going to be the S divided by the T. So just take the S right here, which is in miles. So 28 pi divided by a 12 and also a 5280. And then here's the T, which is 1 over 215 and also a 60 in the denominator. And when you divide two fractions, you need to invert this one and multiply. So the top fraction could stay the same, 28 pi over 12 times 5280. And then take this one and invert and multiply, which means that it's going to be a 215 times 60 over 1. And then how much does all of that equal? So then get the calculator on the screen, and it's going to be a, let's see, the numerator has a 28, a pi, times a 215 times a 60 divided by a 12 and a 5280. So the final answer, they said to go to the nearest tenth, so it's going to be 17.9. 17.9 miles per hour. So with these weekly videos, I've been using the Zoom to make the video, and then I decided to do it the old-fashioned way with a piece of paper right here. If you'd like to let me know what you prefer, please just send me a message. And also, if you appreciate the Easter eggs, please let me know. I've only heard from one trig student that they like the Easter egg. And if this is your first time here, what's an Easter egg? Well, when you watch a video and there's a little surprise, that's the Easter egg. So I said I was going to talk about quiz number 5, which is due on Monday, March 1st. Here's the Easter egg. So if you go into the study plan, here's the questions that you should study for the quiz. So I can't fit the whole thing on the screen at once. So there's 21 questions on the quiz. And my math lab tells me that it estimates that it will take 34 minutes to finish those quiz questions. All right, so like I said, if you appreciate the Easter eggs, let me know. Thanks.